I'm just going to start from the beginning of the concepts of acids, bases, and salt. And basically, this is the chapter of 5 lessons, at least 4 to 5 lessons. Within 4 to 5 lessons, inshallah, you will enable yourself to understand and demonstrate the topics that are found in your exams. Okay, now I'm just going to share my whiteboard here, and I'm going to make a demonstrative chart or a table that will help you to understand the concept of acid and bases. Okay, just I'm going to make a chart here. Our today's topic, that is acid and bases. Inshallah, first of all, we will study about acids, applications of acids, and the chemical reactions of acid. Then we will move to bases and then salt. And just I'm going to draw a structure here. I must. Okay. Now, these are the characters and main points of acids and bases. Just I'm going to make a comparative table that will help you to understand the basic concepts of acids. Okay, characteristics of acids, basic characteristics of acids and bases. I'm using the term basic characteristics. Okay, these are the things. Okay, what are the basic characteristics? I will start from the beginning. That will help you to understand the concepts. Number one, when we talk about the acids and bases, with respect to one thing which is called release of hydrogen and hydroxide ion. Okay, now for that reason, I'm just going to make one of the relation. That's, let's suppose the x means any acid or base is going to dissolve in water, and what will happen? And I'm making one to question marks. Let's suppose the X is acid. If you dissolve any acid in water, it will gives what kind of ion? The hydrogen ion will be released. Okay, this is called hydrogen ion. Hydrogen ions will be released. These hydrogen ions, they are also called what? They are also called protons. Okay, hydrogen ions, in a simple word, you can say that protons, because as you know that the atom of a proton or atom of a hydrogen only keeps proton and neutron. That's why we say that the hydrogen ion will be released. What do you mean by the hydrogen ions? You may use the alternative term, that is protons. Okay, when you dissolve any kind of acid, hydrogen ions will be released. Okay. Now the difference in case of base, what kind of ion will be formed? You may say that hydroxide ion, OH negative ion. OH negative ions will be released. I'm just going to give one example here. This is the basic definition that was given by the scientists. Basically, what they have observed, they have observed, let's suppose I'm just going to draw here one chemical equation like HCl, hydrochloric acid. When hydrochloric acid will be dissolved in water, that is H2O. Okay, what will happen in case of HCl, which is dissolved in H2O? The first initial reaction will be formed. This is called hydrogen ion will be separated or dissolved in water, and chloride ion will be separated. That was the concept. Another thing that I'm going to share, any kind of other acid like sulfuric acid. What is the formula of sulfuric acid? That is H2SO4. Sulfuric acid. In case of sulfuric acid, H2SO4. Okay. Now the same thing will happen here in case of sulfuric acid. When you dissolve the sulfuric acid in water, okay, what will happen? The same thing. The hydrogen ion and the next ion, that is not the hydrogen ion, and the next ion is what? That is sulfate ion will be formed. What is the formula of sulfate? H2SO4. It means that is SO4. And how many negative charges are there? 4 negative charges. I'm just mentioning here 4 negative charges. Okay, now these are the things, they are very much important to understand. In case of any kind of other acid, like any acid that we have, like another acid that we use in our laboratory, that is HNO3. When HNO3 will be dissolved in water, what will happen? The same observation, the same observation. When HNO3 means the nitric acid, when the nitric acid is dissolved in water, the hydrogen ion will be released because it keeps what? This is hydrogen. The hydrogen ion will be released along with that, this is called what? This is called nitrate ions are also produced. And what are the formula of nitrate ion? And that is NO3 1 negative. ठीक है जी? Is that clear?
Yes, sir.
What is the formula of HNO3? That is nitric acid. Now, in all cases, what is the common thing that we have observed? The common thing that is in all cases, this is the same thing that we have observed. In each case, in any kind of acid, the hydrogen ions are released or produced while dissolving the acids in water. Now, the second phenomena that we have personally observed. Now the second phenomena that we can observe here. Okay. Now there was another definition was given on the basis of few things like the behavior of the water, because water can react with acids as well as with bases. But I'm just going to elaborate the second one, the bases, according to the bases. Especially these are the bases that they can dissolve in water. Okay. Now the bases that can dissolve in water, they are basically they are called what? They are called alkalis. Okay. These are called, there are basically two type of bases, the soluble bases and insoluble bases. Soluble and insoluble. The soluble bases, they are simply called alkalis. The soluble bases, they are called alkalis. Now the point that I'm going to discuss here, this is called the soluble bases. They are called alkalis. Alkalis are the bases that can dissolve in water. Okay. And what do you mean by the other substance? These are the insoluble bases. They are simply called bases. They are simple bases. Okay. They cannot dissolve in water. They are simple bases. Okay. Now the definition, that is OH negative ion, that is absolutely okay. That is absolutely okay. Where in case of alkalis, but not in case of bases. But on that time, alkalis were very common bases when the research was going on. Now, I'm just going to give one example and you will get the idea that, like sodium hydroxide, this is one of the common alkali or a base or soluble base. When sodium hydroxide is dissolved in water, what will happen? In case of sodium hydroxide, like when it is dissolved in water, what will happen? It will form OH negative ion. OH negative ion will be formed, and along with that, sodium ion is also released. Now, along with that, sodium ion is also released. That is, what is the formula of sodium ion? That is Na positive charge. Now, look at here. What is going on? The basic concept here. This is what? This is a base. Okay, this is a base, and base, when base is dissolving in water, it is producing what? This is producing OH negative ion. So this is the main difference and the first definition that we obtained regarding acid and bases. Okay, now the second point, the second thing, after some time there was another term has been introduced, that is called proton donor or recipient. That is called proton donor. Don means the hydrogen ion, okay, the proton donor or recipient. So according to that uh, theory, the proton donor acids are what? Basically they release the hydrogen ion, so they are called the proton donors. Acids are regarded as proton donors. They are called, they are the proton donors. Okay, they are proton donors. At the other end, when we talk about the bases or alkalis, they are the proton recipients or proton acceptor. They accept the proton, and this is one of the great things that you may experience such kind of questions in your uh, exam, because these questions has been asked according to XYZ equation. Now describe which substances an acid and which substances base on the uh, reasons of proton donor theory. According to proton donor theory, acids are the proton donors and the bases are the proton acceptor and recipients. Okay, I'm just going to draw here one structure like this one, that is HCl plus H2O. What will happen here? Basically, this is not a complete equation. Okay, what happened when the hydrogen ion and chloride ion has been found inside the water? These hydrogen ion, what they happen? These hydrogen ion make something very, very, very unique thing. Okay, what kind of the thing that we can experience here? This is called hydronium ion. Okay, this hydrogen ion will react with water that is found inside the solution, and this hydrogen ion and water molecule will make a substance. This is called hydronium ion. And what is the formula of hydronium ion? That is H3O positive. Basically H3O positive. And the second substance that we may experience, that is the same thing, that is chloride ion. Okay, now I'm just going to describe what is going on here. Okay, this is basically what, this is a two-step reaction. This is a two-step reaction. Now what's going on? First of all, when we mix the acid in the water, they release the hydrogen ion, and these hydrogen ion reacted with the water, and they make the hydronium ion and other negative charge molecule. This is what, this is called hydronium ion. This is called hydronium ion. Basically, what's going on? The acids are releasing the hydrogen ion, and water is basically accepting the hydrogen ion. Water is basically accepting the hydrogen ion. Okay, this is water and plus hydrogen ion. This is water and hydrogen ion. They both are reacting together and they make what they are making hydronium ion.
So,
So
sir, what happens is when you add the HCl to water, the hydrogen ion in the HCl reacts with the water and forms a hydronium ion.
okay, according to that is basically what that is called the proton donor theory. And according to the proton donor theory, according to that theory, acids are the proton donors. Basically, we have the two reactants, hydrochloric acid and water. And what is happening here, hydrochloric acid is donating the proton, that is hydrogen ion, and the water molecule is a base. Basically, it is accepting the water. Okay, why we use that theory? Because to understand the concept of ammonia, one of the common thing that you need to understand here, I'm just going a little bit detail. Okay, now according to that concept, the one more thing that you can experience in each acid you may find hydrogen okay. But in case of ammonia, when talk about NH3, but in case of base, the base, basically bases are the oxides or hydroxides. These are the oxides and hydroxide. Usually the bases, they keep the OH negative ion. Now in case of ammonia, just like acids, when you talk about the acids keep the hydrogen ion. Ammonia also keep, what is the structure of ammonia? This is the basic molecular structure of ammonia. Ammonia is making the three covalent bonds. Ammonia is making the three covalent bonds, and these are the two lone pair electrons are found on the above side of the ammonia. Now, what will happen? Now you can say that, like, and what is the structure of HCl? This is the structure of HCl, hydrochloric acid. Hydrogen is also making the covalent bond with the chlorine. Now the ammonia is a covalent molecule. Hydrochloric acid is also a covalent molecule. Okay, like in case of nitric acid is also a covalent molecule, sulfuric acid is also covalent molecule. Now because they have the covalent bonds. But in case of what, sodium hydroxide, we talk about the sodium hydroxide. Sodium is what? Okay, this is sodium is a metal, and hydroxide is a non-metal. They are what? They are basically the ionic compounds. As you know that ionic compound usually found in between the positive and negative ions, and the positive ion are usually what? They are what? They are the metals. Am I right? Is that clear, beta? Fatima? Sodium hydroxide is what?
Yes, sir.
This is an ionic compound. But in case of ammonia, when you talk about ammonia, ammonia is a covalent substance, and it has no H, no OH negative charge. Okay, in that case, but according to that concept, we may say that ammonia is an acid. But according to that concept, ammonia is regarded as a base. Ammonia is a base. How can you say that ammonia is a base? According to proton donor theory. According to proton donor theory, you can define that ammonia is a base. How? Like that. Like, for example, I'm just going to work out according to proton donor theory. According to proton donor theory, acids are the hydrogen ion donors and bases are the hydrogen ion recipient. I'm making the structure of ammonia here and an acid. Like this is HCl, and this is what? This is ammonia, NH3. Okay, what will happen when these two reactions, and we know that acid and bases, when they react, they neutralize each other. They neutralize each other. Am I right, beta? Okay, now according to that theory, you can say that now this is hydrochloric acid. It will release hydrogen ion, and ammonia will accept the hydrogen ion. Both have hydrogen, but when they are reacting, hydrogen ion is being released or donated by the hydrochloric acid, but not the ammonia. And what kind of compound they will make? What kind of compound they will make? They will make what? They will make Cl negative, means usually the negative part of the acid, and what will happen, they will make NH4 positive charge. So in that case, what is happening, the solution of ammonia is a gas, okay, the solution of the ammonia, I'm just writing here AQ, the solution of ammonia is reacting and neutralizing the acid. And how it is neutralizing the acid? Because it is getting the hydrogen ion that has been released by the hydrochloric acid, according to proton donor theory. And also, let's suppose, I'm just giving another example here. In case of water, like water, H2O, like water, and this is what, this is ammonia, NH3. Now what is happening here? Again ammonia is getting the hydrogen from the water. In this case also, if ammonia is an acid, on dissolving in water, it must release the hydrogen ion. But what is happening here, ammonia is again receiving the hydrogen ion from where? Ammonia is receiving the hydrogen ion from the water, and it is making what? It is making OH negative charge. Basically, these are the charge that has been released by the water, and again NH4 positive charge has been formed. So ammonia can justify the both things. The solution of ammonia, like this is AQ, the solution of ammonia is justifying the both definition. It is releasing the hydrogen ion. The concept is hydroxide ion are released on dissolving in water. In dissolving water, ammonia is capabling the water molecule to release hydroxide ion. But what is happening here? It is, these are not the ions of ammonia, although, but it is also accepting the hydrogen. So we can say that according to that concept, okay, acids are what? Acids are the hydrogen ion donors, and recipients are the hydrogen ion acceptor. In both cases, okay, in both cases, ammonia is also enabling the chemical reaction to release out the hydroxide ion, but on at that case, it is also receiving the hydrogen ion, like in this one. So according to the proton donor theory, you may find out the two things. You may clarify the chemical reactions of ammonia, because ammonia is a covalent substance and it does not release hydrogen ion, although it has three different hydrogens. It does not release the hydrogen ion. But what will happen here? But will happen here, when ammonia reacts with any kind of acid, it will accept the hydrogen ion, like in all cases, like in this case, the sulfuric acid will release the hydrogen ion to make the hydronium ion here, and nitric acid will also release the hydrogen ion. So in all these cases, when the acids are reacting with the water molecule, though these are the acids because they are releasing the hydrogen ion or protons, they are giving the protons, and in this case water is behaving like a base because it is accepting the proton. But in this case, water is releasing the hydrogen ion and it is behaving like an acid. So we can also say that water is a water is an amphoteric molecule. It means it has the ability to react with acids, as well as it has the ability to react with base. Like in the last case, when the water is reacting with a base, what will happen? It is reacting with, it is releasing the hydroxide like this one. Okay, like the hydroxide has been released, but it is not releasing the hydrogen ion, it is accepting that the hydrogen ion has been released, hydroxide has been released. Okay, now what will happen? These hydroxides will be mixed together with the hydroxides of water molecule. So now you got the point that concept without this concept you cannot say that you cannot explain the concept of ammonia and water. You may experience two different kind of question in your in your examination. Number one, how ammonia is a base defined by the help of chemical reaction. You may use that term, and now you how will you give the answer? You will give the answer that ammonia is a base on the basis of proton donor theory. It accepts the proton when it reacts with an acidic substance, and it will generate the ammonium ion. Like when it reacts with HCl, it will get the hydrogen ion from the acid and it will accept the hydrogen ion or the protons. Like in case of water, it also receive the hydrogen ion from the water and it will generate hydroxide ion. So what can we say that in both cases ammonia is what? Ammonia is a base because it is accepting the protons but it is not releasing or donating the proton. Is that clear, beta?
Yes, sir.
Okay, this is one of the tricky question, and in previous few years I have personally I am observing that these questions are regularly uh, being given in the examination. Okay, now the third thing that you need to understand here, when you talk about acids are what? Acids are the substance they release the hydrogen ion when they are mixed in water or they donate the hydrogen ion. Bases are what? Bases are the substances when they are released in water, they release the hydroxide ion and they accept the protons. Now the next one. Now we are moving about the pH, the concept that you have given to me. pH. When you are going to write the pH, P must be small and H must be large. The pH. According to the pH, acids are the substances they have less than 7 pH. pH is less than 7. I will use that thing. Okay, less than 7. But in case of bases, bases are the substances which pH is more than 7. Is that clear? This is one of the basic concept. There is no hard and fast rule, but you need to understand that how can you say that acids have the less than 7 pH and the bases they have more than 7 pH. Okay, now I'm just rubbing out these things to give the concept of pH also. Basically, most of the people they just find out that the blah 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 blah. But what is the concept behind each and everything? This is very much important. Okay, just I'm going to rub out. Okay. Now, beta, on the basis of pH scale, basically there was a scientist whose name was Sorensen. Sorensen has introduced the pH scale. He just uh, researched on different kind of substances, and he found that on the basis of these theories, acids are the proton donor and the bases are the proton acceptors. He found few new things. He found that a range of the substances, they have different quantity of hydrogen ion and hydroxide ion. On the basis of that concept, he found there are three type of the substances. They have hydrogen ion and hydroxide ion. Okay, what was the concept? The concept was, let's suppose he produced one scale which is called, which scale starts from 0, then 7, then 14. In most of the time, the people start the scale with 1. Okay, you may also start the scale with the 1. Okay, he found that the substances, they have hydrogen ion, like which pH is 0 or 1, they have more hydrogen ion. Like they have what, how many quantity, what is the quantity of hydrogen ion? I'm just going to making like this. Okay, and the substances which pH is 14, they have very less hydrogen ion. Okay, we are moving from this side to this side. We are moving from left to right side. Now what is happening here? If we are moving from left to right side, what will happen? The hydrogen ion are going to decrease. The hydrogen ion is, the concentration of hydrogen ion is going to decrease. Okay, it will take some time, but it will help you a lot to understand that what I need to say, because usually I take the help of pictorials, and these pictorials will help the student to understand the concept. As we are moving from left to right side, the quantity of hydrogen ion, the quantity of hydrogen ion is going to decrease. Okay, so according to that concept, according to that concept, the quantity of hydrogen ion is very high when the pH is low. If the pH is, the reading of the pH is higher, it means the quantity of hydrogen ion is going to decrease. I will not use here like this. Okay, now you are getting the point. When we are moving from left to right side, the quantity of hydrogen ion is going to decrease. So acids are the substances, they have more hydrogen ion. That's why their pH is 7, less than 7. Okay, now you are getting the point. On the basis of pH, when you talk about on the basis of pH, means if the pH is less than 7, it means more hydrogen ion are there. pH, what's the meaning of pH? Potential of hydrogen ion. Okay, more hydrogen ion if the pH is less than 7. If pH is more than 7, it means the less hydrogen ion are there. There are the less hydrogen ion. According to that concept, we can conclude that the acids are the substance, they have more hydrogen ion. You may also write the hydrogen ion. Okay, they have more hydrogen ion as compared to the bases, or they have the tendency to release more hydrogen ion as compared to the bases. What's the meaning of pH? pH means potential of hydrogen ion. Okay, the abbreviation of pH, that is the power of hydrogen ion or potential of hydrogen. So, but you may ask, sir, what about 7? What about 7? Okay, at that same point, we have also, we can say another scale. After pH formation, we have also introduced another scale which is called POH. What's the meaning of POH? The potential of hydroxide ion. Okay, hydrogen ion and hydroxide ion, they are reciprocal to each other. It means if the pH is less than 7 in case of acid, it more than 7, must be more than 7 in case of POH. And in case of bases, it is less than, the POH is less than 7. What does it mean? What does it mean? It means, when we talk about the POH, means when the POH is value is high, the number are high, it means the quantity is less. It means less quantity of hydroxide ion. The less quantity of hydroxide ion. This is also called POH scale. And more POH means, or less POH means, more hydroxide ion. Now, this is one of the technical topic that I'm going to give you in a very brief detail. Even I'm not going in detail to describe that concept. Okay, now according to that concept, more hydroxides are in there. So, what can we conclude? We can conclude that in case of POH, which pH is more than 7, it means they have more hydroxide. Okay, but in case of POH, this is all about pH. This pH, I'm just writing pH. This is pH, this is pH, this is pH. In case of pH, if more hydroxide ion, it means the, in case of pH, more hydroxide ion means the less hydrogen ion there. So the substances which are more alkaline or more basic, it means they have more tendency to release the hydroxide. But in case of 7, the pH and POH always equal at one point. This is called 7, because here, like in case of water, the quantity of hydroxide ion and hydrogen ion, they are equal. How many hydrogen ion there? Let's suppose 1, 2, 3, 4. Then I'll just draw 4 hydrogen ion here, like this one. Got it? So when we are moving from right side to left side, I'm just making another arrow of this side, like this is the arrow of POH. From right side to left side, the quantity of POH is going to decrease. The quantity of POH is going to decrease when we are moving from left side to right side. So in case of that condition, you may say that the quantity of the substances, they have 14 pH, means they have the tendency to lose hydroxide ion as compared to hydrogen ion. Got it, beta? Are you getting my point, Fatima?
Yes, sir.
Okay, this is little bit technical, but it is very conceptual. You need to understand. For a Excel board, it is very, 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 very helpful. Got it? So the fourth difference is that the acids are the substance which pOH is greater than 7, and bases are the substances which pOH is less than 7. But what about the neutral substances? These are the neutral substances. What is the formula of H2O? Water. What is the formula of water? That is H2O. You may also write the water formula like this one, H and OH. ओके, यू में आल्सो राइट, आपने देखा है यहाँ पे कहीं कहीं बुक्स में इस तरह से भी लिखा हुआ है HOH. सो why we can say that the water formula is also HOH? Because the pure water keeps the same quantity of hydrogen ion and same quantity of hydroxide ion when it is electrolyzed. Let's suppose you have the pure water and you prepared a mechanism for electrolysis. Okay, you are just giving the electric current. First of all, it will be converted to hydroxide and hydrogen ion, and the further reactions are formed. These are what the further reactions. By the help of these ions, what will happen? Hydrogen ion and hydrogen ion will convert to form hydrogen gas, and oxygen hydroxide ion will release water as well as oxygen molecule, and ultimately it will make what? This will make this like this one. Okay, this is a balanced chemical equation, and this is the middle part of that chemical equation. When you electrolyze the water first of all converted to hydrogen ion and hydroxide ion. But why the same quantity of hydrogen ion and same quantity of hydroxide? Because water molecule has same quantity of hydrogen and hydroxide when it is electrolyzed. They such substances, they are called neutral substances. Okay, now I'm moving to the next one, the chemical reactions. Now I'm moving to the next one, the chemical reactions of the acids, like acids. When the acid react with base, what will happen? The acid when react with base, what will happen? What will happen when acid and base react chemically? The two substances are formed. One is called water, the second one is called salt. The same thing will happen here. The acid and bases when react together, or bases or acid react together, they form what? Water and salt. Like like how can you say that? HCl plus NOH, it will form H2O and NaCl. Got that point? Okay. Now this is the similarity. When acid and bases they both react together, they form salt and water. Another thing, to pass electric current, which is called electrical conductivity. Electrical conductivity. What about electrical conductivity? Okay, good acids or strong acids. Strong acids are what? Strong acids are good conductor. We will also discuss that. What do you mean by the strong acids? Strong acids are good conductors. while strong bases are not. Strong while weak acids are not. The same thing I'm just going to type here. Strong bases are good conductor while weak bases are not. This is the similarity of acids and bases. They are good conductor in case of strong acids, and strong bases are good conductor. Now we will also discuss what you mean by the strong acids and strong bases. Okay, now we will hold that point and we will discuss completing. Okay, now the next one, I think these are the some basic and fundamental points that you must understand, that what do you mean by such kind of substances. You may also use one of the formula. This is now one of the uh, additional information that I need to hear. Now the pH formula and pOH formula, when you use the pH and pOH formula, this is additional information. That is what, this is the minus log hydrogen ion, which is not acceptable here in your case, so that leave that point. But you must keep these things. What do you mean by the acids? Acids are the hydrogen ion or proton donors. When they are released in water, they release the protons. Bases release the hydroxide. Acids are the proton donors. Bases are the proton acceptors. The pH means the concentration of hydrogen ion. Okay, in case of concentration of hydrogen ion, acids have the more concentration of hydrogen ion and its pH is less than 7, and the bases have the less concentration of hydrogen ion, its pH is more than 7. Why their pH is less than 7? Because they have the less tendency to lose the hydroxide ion, so their pH is more, pOH is more than 7. But in case of bases, the pOH is more less than 7. Okay, now the one more thing, acids and bases, when the acid and bases they both react together, they neutralize each other and they form salt and water. Electrical conductivity, they can conduct electricity in their strong conditions, like strong acids are good conductors while weak acids are not. Usually one more point that I have in my mind, bonding, the chemical bonding. Usually when you talk about the acids, acids basically have what, acids are usually non-metals, so they have usually covalent bonding, or mostly they have covalent molecules. Okay, bonding, when you talk about the bonding or the nature of the substance, they have the covalent bonding. So bonding is usually covalent, that is mostly ionic. Now this is the thing that I need to share in my today class. So what we have studied, first of all, we have found the similarities and differences. Okay, we have found that acids are the substance when they are mixed in water, they release hydrogen ion, while the bases release the hydroxide ion, but only in case of soluble bases, which are called alkalis. Okay, now the acids are the proton donors, bases are the proton acceptors. Acid pH is less than 7, base pH is more than 7, acids pOH is more than 7, and base pOH is less than 7. Acid and base, they react together to form salt and water. They are good conductor of electricity in their strong state. and the normally bonding found in acid is covalent. In case of bases, they are ionic. Okay, the one more thing, there are two type of bases, alkalis and simple bases. Alkalis are soluble in water, but the simple bases, they are insoluble bases. But and we will also discuss in detail what do you mean by the acid and bases in my next lecture. Usually we have acid and bases, like the weak acids we use in our houses, like the lemon juice. The lemon juice keep the citric acid. Okay, our protein molecules, like we have the protein molecules in our body in case of muscles, and we also eat the meats. Okay, protein keeps the amino acids. They also have the acidic part. Our lipid or cholesterol, they also keep one of the acidic part. This is called fatty acids. Okay, now we have different kind of acids in our body, as well as we use these acids in our daily routine. And what about the bases? Like the bases, we also use different kind of bases in our houses. Bases basically are what? They are slippery in nature. So the slippery substances, the chemical that we use, these are the soaps, the hand washes, the creams that we use to soft our skin, the cold creams, okay, and the lotions, they are the bases. And the one more point from that discussion, that you also find out that when you talk about the taste, you talk about, please, 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 do not, do not taste any kind of strong acid. Just I'm just going to give the example. Acids have the taste. What kind of taste the acids have? Acid, the word acid is derived from acidus. Acidus means sour. Sour. When you put some drops of water or some drops of lemon on your tongue, you feel a taste. This is called sour. Usually this is also called sour, but the right pronunciation, that is sour. Okay, now in case of the bases, what is the usual taste of the bases? That is soapy and slippery. First of all, they have the bitter taste. Okay, like have you eaten any kind of almond? You, when you experience or when you enjoy the almonds, uh, and all of a sudden one almond which taste is very, very, very irritating, and this taste is called bitter taste. And when you feel the acids, acids are corrosive. The strong acid and strong base, they both are corrosive. That's why we have one kind of uh, symbol used here. I'm just going to highlight here. I'm just going to share my book page, which will also help you to understand what I need to mention here. When we talk about the acids, like acids are corrosive, means they can damage your skin. Okay, like acids are the substances, these are the things. Okay, I'm not going in detail. I will just complete my lecture in 2 to 3 structures. Like they are very, very, very strong. They can damage your skin, and that's why they have the symbol. Sometime one skull and two bones, and any hand which has the corrosive structure. Now these are the chemical symbols. But one more thing that you need to understand here when you talk about the basics of acids and bases. One indicator, how can we find out that the acid is this particular substance is acid or base? How can you find out? Number one, we use different kind of chemicals, and one of the chemical, this is called litmus. This is called litmus. This is the last point of my discussion, but litmus, we will also discuss the topic of litmus, inshallah, in detail in my next lecture. Okay, litmus. Litmus is a chemical, okay, which has certain color. So acid turns what? There are two type of litmus paper. We use red and blue. You may also use here the red and blue. Okay, what do you mean by the acid? Acid, we write the spell of the acid ACID. Acid ends with D. What's the meaning of D? And we also have the word red, RED, red. Okay, what does it mean? The blue litmus turns red in acid. And what happened? The base, what about the base? The base turns, the base may turns to blue. Okay, so acid turns the litmus red. Acid turns the litmus red. I will use the term here, red, RED. And the bases, I will use the next color here. The basis turns the litmus color into blue. अब इसमें बड़ी बेटा एक मजे की बात आपको बताऊं, just for the understanding. What is the starting letter of base? That is B. That's why we use the litmus color blue. When you put the litmus in the base, it will turns to blue. This is this is the litmus color. Okay. Now, one of the interesting thing again. What is the last letter of acid? That is D. What is the last letter of red? That is D. So you may also find out that acid may turns the litmus red. So this is from my side. Now we have the section of we have the session of question and answer. Is there any kind of ambiguity in your mind? Please do let me know.
No,
Fatima,
sir.
is everything okay?
जी सर.
बेटा कभी कभी तो कुछ सवाल आप लोग पूछ लिया करें, जो ना, मुझे कभी कभी अल्लाह ताला की तरफ से, चलें अच्छी बात है, लेकिन कभी भी कोई भी एम्बिगिटी हो, आप इवन मुझसे ये भी पूछ सकती हो, सर ये एसिड के अंदर आपने ये क्वेश्चन मार्क क्यों डाला, ये क्यों किया, ये क्यों किया, ये क्यों किया. नाउ दिस इज द थिंग दैट आई नीड टू शेयर. Thank you very much. It's a very nice and humble class today. You may take the snapshot. Snapshot ले लें इसका बेटा. अच्छा, प्रोटॉन डोनर थ्योरी का कॉन्सेप्ट ज़रूर रखिएगा, ये सवाल क्वेश्चन बनकर आता ही है. इज दैट क्लियर?
Yes, sir.
ओके, thank you very much. Inshallah, I will also upload that lecture on my YouTube channel. You may also get uh, any kind of revision, तो आप वहाँ से उसको रिवीजन ले सकते हैं. मेरे ख्याल से इस ये एक वो ऐसा लेक्चर मैंने डिज़ाइन किया है जो कि मैं कोशिश करता हूँ कि पहले इसको बच्चा पहले पढ़ ले, देख ले, समझ ले, उसके बाद उसका एसेट का और बेसिस का बेसिक कॉन्सेप्ट सही हो जाता है, उसके बाद हम डिटेल में चलते हैं इंशाल्लाह. फिर हम नेक्स्ट में हम बुक रीडिंग की तरफ भी आएंगे. ओके, थैंक यू वेरी मच. अल्लाह हाफिज़.
Allah Hafiz, sir.